course, now it went away.
There we go. We can see your slides.
All right, so Glenn did a nice job of talking about the whole system together of this blind rate mate rack manifold. Tim went into the details of the QDs themselves. I'm going to be talking about the rack manifold that mates one of those QDs. So again, my name's Scott Stammer, engineering project leader with Invent. So the goals of this project, as Glenn described, was to fit this in the standard OpenRack V3 and to accommodate both the 3 and the 5mm quick connects. And we want to obviously provide uniform fluid distribution across the whole range of IT gear from the top to the bottom of the rack. And we need to locate these quick connects within a very tight prescribed tolerance range. As Tim had detailed, there's a lot of tolerances that go into this whole system, and we need to make sure those QCs are located properly to make that proper connection. And we want to make sure that this supports a variety of coolants, such as PG25 or other fluids that are going to be used in a typical data center. And we want to also minimize the impact to the server fan size and count, trying to make this as compact as possible to make sure that you still have full access to all your IT equipment, that adding this additional manifold in the back of the rack isn't going to interfere with any access or minimize any equipment that you might want to put in that rack. So the interface to the rack is mounted to the top and bottom of the rack. And as you can kind of see in some of these views here, it's very compact. It is still being worked out, the details of the actual attachment method, but this is kind of showing that it would be mounted to the top and bottom frame rails. Very narrow profile, again, to make sure that we're not obstructing any access to the equipment, trying to minimize the footprint here. And particularly on the bottom, really opening that up as much as possible to get access to that leveling foot. We realize that needs to be adjusted on every installation. So we want to make sure that a standard tool still has full access to get in there and adjust this leveling foot to level the rack without any obstruction from this manifold. We're looking at rear cross supports, so some supporting channels that would go across and help transfer that load from the QDs through the manifold to these cross members, which will then tie it into the rack. What that's going to do is really stiffen this manifold to help ensure that these QDs are located where they need to be, both from a tolerance standpoint and loading, and make sure that we're always getting good connections there. And because we have that structural tie to the rack, then that allows us to simplify the manifold structure. We don't need to build in all that cost and complexity to that manifold. We can put in some simple cross members and tie that whole system into one integrated unit. And then possibility is to have some adjustability to that connection from that cross member to the manifold, and that will really allow it to be dialed in case there's any variation in the rack or the manifold or different things at the installation. The customer can adjust that to really put that manifold exactly where it needs to be to make that good connection. So as we've talked about, the tolerances are key. There's definitely no understating that here, that tolerances on a blind mate connection are critical. And not just because of the position, as Tim referred, we need to make sure that these are aligned within the gatherability of the QCs, but also that this is robust enough that it doesn't deform under load. There's a spring pressure inherent in the QD mechanism itself, as well as the water pressure. There's water pressure trying to force these two QDs apart. You put those two together, water pressure and spring pressure, and by a rack full of QDs, and you've got several hundred pounds of side load on this manifold, and this needs to be able to resist that. Because as it deforms under that pressure, these QDs will start to extract from one another, and there's quite a bit of allowance for variation in that, but at some point, if it pushes out too far, it actually starts to close, and then you're going to lose flow. So we want to make sure that we stay within that range where it's going to be reliably mated and within the tolerances and have good continuous flow through all the QDs. And there's, again, wide rack level tolerances. These are sheet metal. They're very good quality racks, built very well. All the components are very good quality, but there's naturally tolerances in everything. You stack all those up, and this needs to be able to make it between the QD and the manifold. Everything needs to be able to handle that variation. And again, we have limited space for that manifold profile. We want to make sure that we keep it as open as possible for IT equipment access. Glenn mentioned the vent. We do have that integrated in the top of this. This is kind of showing how we have this support structure around it that besides relying on or this performing the structural attachment to the rack, it's also providing some encasement for this vent so that during handling, this is going to be a very large, heavy assembly. We want to make sure that that vent doesn't ever get banged around and damaged. So we've got these flanges that will help protect that. And that's designed to accommodate a variety of manufacturers' products. It's not tied into one vent manufacturer. We want to make sure that we have a lot of flexibility there. And it's easy to replace. We mount it on a quick connect so that you can easily pop it off and you don't let any air into the system. You don't have to drain the whole system just to replace a vent if there's ever a problem. And another benefit of that QD is that you have a place to attach the purge hose or fill hose. If that's what you'd like to do during initial commissioning, you can remove the vent, pop that on there, and that oftentimes is a much quicker way to fill this. And then if in production, if you want to put the vent back on, then that will take care of any air that happens to make its way into the system over time. Hose will, as a standard product, will mount to the bottom. It exits at a side at a 45-degree angle from the bottom of the manifold. And that really allows a lot of flexibility in where this hose gets routed to be able to go to either an in-rack CDU or row-based CDU, as well as just make sure we allow access to that leveling foot again. And there is another version of this that will have a top feed if you want to do a sealing manifold. That is an option. Manufacturing concerns, again, it's a very large, heavy assembly. It could be made out of a tube or extrusion, and we want to make sure that this is something that can be built in the spirit of OCP by multiple suppliers, that you don't have to have too specialized of an operation to be able to make this. And it could be made out of a roll form tube or an extrusion. There's benefits to both. So different manufacturers may do it different ways, but the end product will still be compatible and they'll perform the same function. We looked at FEAs of a fully loaded rack, make sure that the deflections are still within the limits, no problems there. We also looked at what if only the bottom is loaded, because that, assuming that there's only one center stiffener, actually the top of the manifold will actually bow in a little bit, but again, still well within the tolerances, so no concerns there. And then flow distribution, we looked at that to make sure that it's even flow. We used a variety of tools to accomplish that. And again, call to action, we definitely can use additional input from other members of the community.